Excellent. So what is Trimble Stratus? We'll just start, briefly with that. If we summarize it in a sentence, it's an online site information tool that makes use of drone and other sorts of data to help companies manage their sites. When we talk about Stratus, we talk about it as having three main sort of elements or components. One is the data processing. The second is the online display and analysis. And the third is sharing ability. So what is it? Where does it come from? If you're familiar with the name Propeller at all, they're an Australian company who developed this software and this service in partnership with Trimble and its dealers. The product is sold as Trimble Stratus. We've been working with Stratus since the end of 2018 now. So it's very much the same product, but operating through our channels allows us to tie in with all the other related technology that we're selling and supporting, whether that's the drones themselves or TBC software, machine guidance, Vision Link, the use of Trimble Connect platform, things like that. We might touch on a little bit later. I thought I'd just note, being an Australian team, we have a really good relationship with Propeller, and it really helps us to get some discussion ideas and development and things happening to make sure customers have or potentially would have what they want. So what you're seeing today is, this is the current build, but being an online software, they do refine and improve and add things reasonably often, which is always good to see. Okay, what are we looking at? So the first thing we might sort of talk about is uploading some data processing. So create a new data set essentially. So this is just a web address. And it'll give us a couple of categories. It'll say, hey, where's the data going to go? So data is treated in sites. So a site is a specific continuous extent. So there is an upper limit. If you're building something incredibly large, you may want to split that into different sections. But generally a site could be one house block or anything up to a full mine. And we've got a map to manage that and a list to select, so we can sort of navigate to what we're talking about. Several different categories of data input that we can provide here. And it'll give us a little spiel. The traditional one is the drone survey. So where we use our drone flight planning software, we capture our grid of photos. We've got a GCP file from somewhere. We upload those, away we go. We can set filters on that, determine what we're going to use as check marks or ground control. This can take RTK, PPK data with fewer ground control points. Basically an upload process, and we'll get an email within sort of 24 hours to say, hey, that's all ready, which is great. Other options we've got are pre-processed data. So we might have put some data through Pix4D or something like that. We get the GeoTIFF outputs from that one there, upload that in much the same way. Point cloud, we can work with point clouds from whatever source, whether that's mobile laser scanning or terrestrial laser scanning, possibly the drone point cloud in that different LAS form. So that's more recent, probably within the last year. I think that one was added based on requests, design surfaces, and we've got another way to put that in later as well. So basically we would follow through that process until we get an email saying, hey, it's ready. Within that email, we would have a link to go to our processing report. So I'll see if the specific data set I'm looking at has got one. So this is a standard sort of, hey, well done, standard sort of photogrammetry processing report you'd expect to see. It's giving us our classic live demo experience. Fantastic. So here's one I captured up in Darwin that I should be able to show. Excellent. So I had a bit of an experience with some pretty serious rain clouds coming through halfway through. But this is what we're getting is an extent, the positions of our GCPs, our image quality, the ratings of what the quality perceived from those is, and then there's a few factors behind that. Probably more in the poor section than I'd like, but we can kind of see what that might be about. Positional error, residuals of my ground control, nice and tight. This was an RTK flight, and there's some more breakdown on that. Checkpoint. Excellent. But there's some links through there to go into a bit more detail, but basically just making sure what we've uploaded has been appropriate and correctly processed. There's some more checks going on there beyond just looking at the specific data set that it's been given. Once there's more than one data set, then the service is actually checking them against each other. So around the boundaries of our site or on permanent roads where we wouldn't expect any height change, they're looking for tolerances to make sure that we haven't done anything strange with our ground control or anything else like that. So, we'll have that confidence that the data we're about to look at is accurately processed, which is good. All right, some analysis. So this is an American landfill. We might get some pop-ups telling me that I'm view only, things like that, but it'll do everything we need. Great. So what are we looking at? What's going on in front of us? This is our 3D window. So just panning around that one, moving that with my mouse. This is where we're actually sort of viewing the data that we've been given. Okay, over on the left, we've got some tools to analyze that. We're going to come back to that. This is where we can select our site and our specific data set. So here we've got a couple over a year or two spread out, those sorts of things there. So we're looking at the latest at the moment. If we wanted to roll back to the previous one, we can do that. So here this landfill's being built up, so we'll expect everything to be lower and smaller as I fly further back through dates. Beautiful. All right. Over on this left-hand side here, we've got our display options, I suppose. So what we're viewing now is the orthophoto draped onto the 3D terrain model. Okay, and we've got some edits in there. So as part of the processing filtering that's done, we've hopefully had all of these vehicles removed. Okay, if we find something that hasn't been removed perfectly, say this here, might have been a vehicle there rolling through. We've actually got the option to come in and select around that and edit that, flatten that out, and store that as a terrain edit ourselves. We can view the point cloud. So much the same data, except that the point cloud is going to be served up to us raw. So we will actually now see, takes a fraction longer to buffer in, we'll actually see the unedited data behind that. So we can see all those vehicles now. So sometimes nice to tick that on or off if we're just trying to work out what is this lump or thing or concern that I'm looking at. Do I need to do anything with it, or is it actually correct? And then a couple more here. If we've flown the drone and processed the data through Stratus, we've got access to the camera positions. So for those who are a bit more familiar with the drone photogrammetry side, if we are looking at our data and then investigating, why is something looking a bit strange, this is one of the things we could start to be checking up on. But essentially, for those who aren't as familiar, we've got a drone with a screen on it. We've said, hey, here's the extent of my site. I've put some settings in and it's gone and flown along and taken photo every couple of seconds, I think that is, every 1 or 2 seconds, something like that. And that might have taken 2 flights, 25 minutes maybe, something like that. And afterwards that's done, we've got all the photos, and hopefully we'll have some ground control. No, not in this one. Anyway, we would have a CSV out of our rover or that we've been given. We've got a couple of other tools in here I might come back to in a little bit, but let's get into some measurement, some assessment. So point, line, and polygon, everything falls within those categories. Point's not super exciting, so we'll breeze straight through that. Just marking something out as a point of interest. We can take a spot elevation history, which is okay, but we'll come into something a little bit more exciting. Road grade or slope angle, interchangeable terms there, I suppose. I've looked at this section before, and I know it's on the slightly steeper side than some of them. And if I work in a specific sort of view, I prefer percent. Very good. I've got that chart pop up. I can hide that for now if I want to. So that the average over that section there is 4.4%. So if I'm trying to make sure that for these larger, heavily loaded trucks, I'm complying with A, safety, and B, efficiency, that needs to be within a certain tolerance. If I get rid of that one and do one a little bit further around this curve, it's a little bit more. Okay, cool. So if we've got a threshold to meet, we can actually go ahead and check that. But that's just being reactive, I suppose. We're checking one road at a time. If we fly back to this survey section, we've got a gradient tool here. So we could actually start to colorize our site based on what is and isn't acceptable to us. Okay, so I haven't tidied these up as well as I could have, but we can see here green is very low, 10 is that first sort of yellow color, and this section here that I highlighted before, there's a fair bit of yellow going through there. So if I tidy these up a little bit more, we might actually start to identify that again over on this part of the road here. So I can make this more transparent if I go the right way. So there's a road over on this southern side here, and we can see that that's significantly steeper. All right, and if I identify that with this tool, I could then potentially come in and create a fresh measurement on that. I'll just slow down a bit because I'm racing through. There you go. So chances are that's probably a bit steep for anything large. And we've got this chart pop up here as well. So this one, I might save this one, but we will come back to that. So that's a simple, specific, single analysis. So we can do that off any one data set. Another example there would be something like a stockpile. So what if we got over here? It's a little bit, yeah, it's just this little baby one here. Cool. Huge long list of tools here. Okay, we don't need to worry too much. Everything can be done out of this single basic volume measurement. A lot of these are sort of pre-selected templates with a specific name, but we can have these named and combined for our industry. So there'll be some specifics that are landfill terminologies here in this type of site, and in others we might have some different ones. Not too worried. Stockpile. Click a boundary around this. And that's going to calculate our values for us. So that's 13 cubic meters. Okay, I've got two sort of ways to visualize that if I want. One is this sort of 2D heat map. And the other is my 3D, which doesn't want to load right there, but that's all right. We'll find one of them in a moment. There we go. Thank you. So that's our representation, and that gives us a pretty clear understanding of what's that actual boundary I've drawn and what does that plane do, and how has that measurement been taken? Because I've just clicked on that, and we can probably start to see if we look closely enough that is not flat ground there, so there will be some slope in my measurement plane, and we've got a number of tools to address that given here. So smart volume is what I've done. Reference level, we can cut from a specific RL. a volume compare. So if we've got a pre-existing survey, or if we have a stockpile pad that isn't flat and we've surveyed that previously, then we can put that in as the base surface just to make sure that this volume calculation is accurate. Excellent. We can add materials to this. So great. I know what the volume is. Usually I might jump off and calculate something in Excel. A value perhaps. In a landfill case, it's often a density is important. They know the weight of the trucks that have come through the weighbridge. Once we start to know the volume of things, we can calculate the density, and we can have those persist throughout our site so that everybody's working off the same thing, and so that the calculation is done and displayed right there in front of you nice and easily. Excellent. All right. Next thing I'll show is a imported design. So this is as a design file been brought in. There's a button here. We just drag and drop it in. This could be a TTM or a DXF in the 3D space. We can also bring in 2D features with either probably a DXF or a KML. And we'll have a look at one of them later. But this is our 3D representation of the design, the pyramid that they're trying to build up to. And we've got some rough ways to overlay that, I suppose, and see that, okay, well, the edges of these batters are a little bit higher than they should be, and maybe that's on purpose or not. I think that view's a little bit rough, personally. We've got some nicer ones. If we come in and look at this same sort of southish corner again, I've got a compare to latest design tool. Again, at the moment, I'm just clicking randomly based on having a look at the thing visually, but we'll see later how we can actually formalize what that boundary is. Okay, compared to a specific thing. So we're working off the displayed data set here, which is March last year. And if I change that, then I can do the calculation off something different. I'm going to go to that single end of life design. So there's only one design in here, but you could have several. You could have plenty. So this is, final. I don't know how long the life of this project is, but you might have a monthly goal, you might have a quarterly goal, a yearly goal, and then a final. Great. So we have significantly more fill to be done here, and the 3D cut fill's just booting up for us. There we go. Thank you. And this gives a bit better sort of visual reference in my mind about the comparison between one and the other. So now we can start to appreciate a little bit more where, within what I've drawn there, where is this number? And it's obviously going to be up this end. Back in the 2D cut fill, I've got a spot height as well. So there, that'll quantify for me that I've got 10 meters of fill to my design. Over on this boundary, it should be very close to 0. That's correct. And down the bottom where the site is 1.5 meters high. So something to look at. Awesome. All right, I'm going to jump into a different site, some different examples. Okay, so this is an Australian example of a coastal development. And there's again a number of data sets over the previous couple of years. So a lot more going on, a little bit more hectic than just, okay, there's a pyramid they're trying to build up. So I'll just give you a bit of a background. This was the first data set that's up there, so not exactly prior to construction, but certainly a little bit less going on down here. There's some nice strange features over there that haven't been edited out. Move back to the second last data set. Excellent. So that that can be quite a useful tool, is to actually get a bit of a feeling of what we're looking at in this data set compared to if I flew last month or if I flew a year ago. There could be some pretty significant changes. So down the bottom here, there's a timeline slider tool, and I can fly through that. And at this point, it's just changing the photo that's draped on. This isn't changing us between the full 3D base surface. We need to do that up the top here. But this is pretty handy if we're trying to look at, and my sort of example is down into this section here. Not much going on, no real roads in there. Okay, starting to have some of those put in. Okay, the lots themselves look a fair bit closer down here. Okay, we can slide it through if we like that. All right, starting to see some actual construction moving to buildings, houses themselves there. So a pretty quick tool to sort of give ourselves an idea of what's happened over what length of time. And similarly, if we were pursuing that end and we sort of didn't quite feel like we understood what something was, what it looked like, we do have the option back here to look at our photo viewer. And if we click on a specific spot, double click, I believe, having a think on me. There we go. We can access the individual photo that was taken, and that's showing us that one's highlighted here. And for some, this view might be a little bit more helpful, and it's certainly going to contain a little bit higher resolution if we're looking at something specific. So sometimes handy in just painting that picture of what's actually happening on the site. Okay, over here we've got a what I'm very confident will be an artificial lake. So I'm going to take a bit of a look in at this section here now. So the design, we do have one loaded in again. This is a pretty large one, so it'll take a second. It's giving me a warning there. It's saying it's not small, it needs a second to load that one up, so we'll let that do its thing. But we'll come back into the measure section, and we're going to do a cross-section comparison. So over a long, there we go, designs come in. So we can see for the lake section, it's actually not conceptually too different to where it's at now. And again, we can try that overlay tool if we think we like that. So we can sort of see that all of these tiering, these steps are roughly as intended at the moment. So we'll turn that off. So this section is mostly complete, I suppose you'd say. And we'll run some analysis of that. So cross-section comparison. Excellent. So noting that's 0 on my graph, so this is below sea level. And as I move my slider over my graph down the bottom, let's get that out of the way for you. That's reflected in the 3D view, so I sort of know where I'm looking at quite specifically. All right, so that's one cross section. Great, cool. If we want to be a little bit more interesting, we can add the design surface in itself and start to do that comparison in that cross section. So we'll see if that needs a little second to think. Beautiful. Okay, so if I zoom in, and I'm just using my scroll wheel zoom on the graph here, I can see there is that white dotted line, but it's very much the same as the current survey, suggesting that work's mainly complete there. We can, in that little differential I highlighted on the crest here, we can see those figures down the base middle of the screen that's saying there's 300 mil difference there. So they're 300 mil below design at that point. So actually quantifying for us what we're looking at. Great, let's fly back and add the earliest surface that was taken. Having a little bit of a think on me, that's all right. So it might be a little bit hard for you guys to see through Skype, but there's a dark blue, purpley coloured line here. Probably a little easier up here. So we can see that over in the lake itself, there's been significant removal of material in there, 10 meters at that point there. And then again up at this sort of temporary site road level, not much has changed. They haven't had to do too much there. But okay, well, we know now we've got 7-8 meters of difference or more over at this point. That's in a 2D view. Let's consider that in 3D now. So I'm hitting discard on all these measurements, but I can certainly keep these saved if I wanted to. No, we're going to do a comparison to previous survey. Okay, from here, I want to go back. Previous survey will default to just the last one numerically, but I think I looked at the first one, so I'm going to go all the way back to that. And I really like my 3D view, so we'll get that one buffering in. Okay, so they cut 35,000 cubes out of this section. Running a little bit slower through Skype on me today, thank you. Okay, so we saw over on this northern side what that cross-section difference looks like, and this has just given us that 3D consideration we didn't have. So over on this end, I can see that the base of that surface was significantly higher. So not quite as much work on in there, but certainly still a bit of moving. Great. All right, so in the previous example, I looked at comparison to the design, and this one I looked at comparison to a previous survey. Let's take the next step on that and put the two together. That's called an Earthworks progress template. Essentially, this will allow us to spit a nice report out of our progress. So from the last survey or a specific one, so let's say from last month to this month and then forward to our design, let's compare how we're tracking. So we want to compare with that last survey in the design. Okay, so we saw that number before. It's fractionally different because I drew it differently. Yeah, and it's doing its crunch on the comparison to the design surface. So doing about 3 things at once there, so it will take us a second to buffer that in. But what we should get to is a graph, a chart here, showing us how we're tracking towards our design. We'll just give that a second. Beautiful. Okay, so this graph has actually taken the next step for us. It's added in all the other data sets that exist, not just the ones I've selected. So what I've selected here is about what I'm visualizing in my 3D view. Whoopsie daisies. What I want. But my chart, my graph here is for everything. So back at the start, when we saw we had that pretty significant difference between now and then in design, we trend down. So the cut that's required is trending down over this time period, and it's not perfectly even. But let's say we did one every month. This would look nice and regular, and we'd hopefully see a linear decrease or whatever sort of rate of effort we're going for down to now where there's 300 cubic meters difference in that section. And I'm sure if we did the maths on that, we're going to be much less than 1% at that point, so probably nothing to be worried about. So a pretty nice way for us to graph and track our progress. We could draw this across the whole site if we wanted to, very easily, but also in a specific section. All right. So I mentioned before that we can create a report on this. Yes, it's nice to look at that there and go, cool, that makes sense. That's what I'm hoping for. But we may need to do a bit more with that information as well. So I can make a PDF report of this one. And this is just a preview, but essentially we'll get a little bit of a basic formatting with that measurement that we've conducted before, that earthworks progress. So that'll give us our numbers that we saw there, so 33,000 cubic meters, and then whatever's left to the design. There's our little site map to show the context of where I drew that boundary. And I realize you probably can't read the numbers on this being so small, but this is our earthworks measurement. So from data set 14th of February to our design, there's 150 cubic meters difference. So that's what we saw down the bottom there, was very, very little difference. Great. Between our data sets that I'd selected, so February of each year, 30,000 cut. Also a heat map with some spot heights, some spot differences, and some more there again. So as it says there, I can punch this out. That might take a couple of minutes, and then I'll have access to that. So a more formalized way to show that information. The other option we did have there is a CSV report. So if you've got some systems you already want to put that into, great, get that information out. There you are. So between the three of those, I think there's some pretty strong ways to view what's going on at the site or within a specific site area level. All right. All right, that was the primary sort of progression of the complexity of the tools I wanted to go through. We started with a point, we did some more interesting things with a line, and then we worked up to the area, and that earthworks progress where we're combining things is probably the most exciting. We do have a number of other features we're probably likely to use though. One is this export map. Essentially we can specify an area if we want to, but that'll punch out a nice simple site PDF. I've clicked that. We'll see if it, I don't need to minimize my browser for that to punch out into my downloads, but essentially, yeah, punching out a really quick, easy PDF that we could be printing or putting on the office table or whatever it is we need to do. Files, I haven't mentioned this one yet. So we spoke about uploading and processing and checking our data's been correctly processed. We've looked at some of the analysis we can do within the Stratus portal, but there's certainly going to be times where the things I've showed you isn't the whole list of work you need to do, and that's certainly recognized. So files, we can always access our processed raw data, I suppose you'd call it. And normally we get that in a little bit of a folder if I find a newer data set since that change has been made. Let's see. Beautiful. All right, broken up for us there. So the ortho photo, we get some low res and then some high res and the whole shebang. The point cloud, okay, again, there might usually be a lower or full resolution on that, and then a number of different formats. So basically, depending on what you want to do with the data, you can pull it out in a number of different ways. That's for the site-wide level. One of the tools I quite like in Stratus is that if I draw an area, same one, and I hit export, I can punch out a DXF or a LAS or a point cloud format of that surface at a specific resolution as well. So I might have think that was 500 meg point cloud, not too bad, but that might be a bit more than my computer or my workflow can handle. So I might say, right, well, I don't need the whole site at full resolution. I only care about, you know, certain bits. I've already got all of this. Nothing here has changed. That's just file size that I don't really need. So I could draw whichever number of areas I needed and export that and say, right, well, I know I can only really deal with 100 meg, so I'm going to sample that down to 25%, okay, and pull that point cloud out that way. In the Trimble workflow, certainly, you know, one of the things that Stratus is not meant to do, it's not meant to be able to create design files for us. You know, within our stable, that's still a TBC process. So we might use Stratus to intelligently take out the bits of data we want at a useful resolution, and then work that up into a surface and do our design there in TBC. I've got a number of other options through the exports. Once I finish through this little wizard, I can punch it as a direct download. I can apply it to Trimble Connect. So if I am working in our Connect workflow, we can start to use that just to make things a little bit easier and more clean. All right, but this is the next thing I wanted to show, which is share. So I've been driving this all in my browser. Great. You could have been too. So Stratus, the concept is it's all just login based. If you've got a computer and, you know, a hotspot phone connection or better, then you're away. I can share permissions for my whole portal, a specific site, whatever I want to do at specific levels of permission again. So I'm not going to make everybody in the call an admin, but I could say, hey, great, you know, I type in your email and I can make you all view-only users. Okay, or for somebody, I might want to say, no, I want them to be able to create their own measurements and save and export them and do that. There's a nice little menu for us essentially to manage that. So, you know, for some of our bigger customers, they've got, you know, they're working on lots of different people's sites. They certainly don't need everybody on the same page. Just this site here, access will go to a select team. The next site will go to another list of emails, essentially, just to make sure that's all managed intelligently. So I can do that at a site-wide level or at a specific measurement. So I could share this. Here's a link, bang, off you go. And basically you click that link and that'll bring you right into, let's do one that's actually worth seeing. But when I did that comparison to previous survey before, give that a second. If you click that link I'd sent you, that'll bring you right into this measurement. So instead of me having to really explain what I mean and how I mean it, click that, oh, right, I get it. Over on this side of the bank, there's this much work to do, okay? Or it'd be the graph or whatever it was. So a really easy way to share what you've measured or analyzed, share that with someone's, or allow them to change it potentially if that was what you wanted to do. I'm going to take one more site example just to show a couple of features that have been uploaded into this one. There we go. So residential build over in the US. I won't bother giving you too much background on the site. Suffice to say that there is a design brought in, but not just that 3D purple design before. This is our actual DXF with our components, different terms for that, depending on what where we come from. Layers is probably the best term. So I brought in, somebody's brought in the lot boundaries here. So all my measurements today so far, I've just been clicking bang, 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 bang. You know, okay, for some that's perfect. Sometimes we might actually want to use a defined pre-existing boundary that makes sense to everybody. Okay, so if I turned all my labels on, lot whatever this is, okay, right click on that, convert it to a measurement. This might be in one of those scary foreign unit systems. Yep. Cool. Right. If I brought that information in for everybody, then I can actually make sure that everybody's talking on the same page. And I could have potentially drawn that here. I can draw features and surface areas like I showed before, and I can have them saved. I may decide to export that and re-import it as a design surface, just to make sure everybody's working in the same concept. But we will see in our measurement tab that I can organize and store a lot of measurements. Okay, we've got some tools to filter that for just what I've done or just what a certain person, whatever. Organize that by folders, view oldest, newest, things like that. And then I can turn on and off and just start to see what else everybody's been doing here. If I've got back in that example where I have a persistent boundary like this, or maybe one that I've drawn, I've got some options. I can what's called promote it to site level. I can have that as a persistent boundary, I suppose. So I could run maybe not the best example here, but in one of my previous data sets, I could run a compare to previous survey on an area and have that set up so that as soon as I uploaded some new data, so next month's data, that would recalculate that same result, which is compare from current month to previous month, and it would automatically recalculate it on that boundary for us. So I could come in, and I don't have to go click through each one and say recalculate, 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 recalculate. It's all there, great, cool. Click on it, bang, or tick them all on, PDF report out, or CSV report. So some nice tools there for us to be a little bit more robust in our analysis, I suppose you'd call that. Awesome. What else did I need to show? There's not too much else that we haven't been through. We've got a couple of basic settings. I think I showed, there's one I missed. I showed the gradient map. We do have an elevation map as well, contours on and off, and I can colorize that in a certain way. So the obvious common example here is if we're talking about drainage or flood or something like that. But I'm sure you can probably think of something else you might want to apply this for. Certainly know that it's probably more on the gradient side, but elevation and gradient play a bit of a role in bushfire and risk analysis as well. Awesome. And same as the measurements, we can organize and filter and group our designs in much the same way. Excellent. So that covers probably the primary functionality of the portal that I wanted to talk about. I just list a couple of sort of specific workflows people have had or used or had some success with, and maybe just light off a little bit of a spark there, but we'll hit some questions shortly if there are any. I can, if I fly back to the one I'm a bit more comfortable with, I spoke and showed before the whole site was flown with the drone. Okay, we might come in next time and say, right, well, I've got all this stuff here I don't care about. It's not my land, or I don't care, or it's trees, or whatever it is. So I could potentially be drawing a slightly more accurate flight boundary. Probably getting that piece there, but I'll just smash this through so don't waste your time. And I can export the KML boundary of that one, take that KML boundary out into my drone flight planning software and just make sure that's the bit that I care about, that's what I'm going to get. Okay, because sometimes, and you may have experienced it on Google Earth or something like that, but if we just draw something off an ortho photo, great. But if we're not actually all in the right coordinate systems, it doesn't always cut the mustard. So here, this data is all spatially correct based on what we've put into it. So that KML will come out correctly, and again, probably just a little bit more robust on the flight capture component. While I'm on landfill, we've had people look at or succeed in integrating vision link data. So the drone here has been flown every second month or something like that. Certainly these machines should hopefully be working all day, every day, I suppose is the idea. for those who don't know it, VisionLink is a system on a machine where it's essentially recording the heights and the movements that it's doing. So we're actually tracking a surface that it's creating. Essentially, if you think of a bulldozer or a compactor, if the base of its wheels, tracks, whatever is somewhere, that's where the surface is. So we're using GPS primarily systems on the top of that to say, right, well, I can know where that's been. I know what that surface is. I can pull that data down. I can pull the drone data down into TBC, combine the two together, and then re-upload that as an updated design, which isn't a design as such, as it's more just the drone data where that is the latest and greatest. And then in the actual working area, this one here, where the machine data is much more recent, we can have that stored as the primary surface that we're going to do calculations off. So instead of doing all my calculations just off this this March data set here, I might have March 30th in that one there, and I can calculate that way and just have that latest and greatest data over in this working section here. Incorporation of terrestrial laser scanning data. So you may have seen at the start I showed we can upload data in point cloud form. UAV data, great, got a lot of applications, but there's certain things it can't do in terms of operating, really capturing under the sides of bridges and things like that. Yes, technically there are ways we can do it, but often there's urban environments, parts of the world that don't work very well with drone data to produce a nice looking point cloud. So you may integrate some terrestrial laser scanning, some mobile laser scanning as well, potentially merge that with the UAV data set and then re-import that point cloud so that you're not missing that piece of infrastructure or that feature that you needed that TLS data from. So we've seen that once or twice as well. Jumping back a step, where I was talking about the VisionLink system, Propeller themselves introducing some more machine productivity tools, I suppose you'd call it. So their product is called DirtMate, which essentially is a lightweight, simple, easy GPS antenna system on top of a machine, and you just it's magnetic, so you just plop that on top, and that's going to transmit back to the Stratus portal and show us their movement and their utilization and productivity and some things like that. So encourage you to have a bit of a Google if that's anything that'll be interesting to you. What's next? If you're interested in, if you've seen something you like or you want to keep learning a little bit further, there isn't a public access to those demo data sets that I've shown, but if you do want to have a bit of a play, just reach out. I'm sure we can organize that. That's publicly shown data, so it would not be hard for us to get you in front of that to have a bit of a play, or if it's with some of your own data, you really want to see what that looks like.